Okay, let's look at a problem. This is the Blue Ridge hot tubs problem on page 21. You can see that for the background information. When we're formulating a linear programming model, the first step is understanding the problem. So I want to read this. You need to look on page 21. Blue Ridge Hot Tubs manufactures and sells two models of hot tubs, the Aquaspa and the Hydrolux. So they make two products. Okay. Howie Jones, the owner and manager of the company, needs to decide how many of each type of hot tub to produce during his next production cycle. That sounds like the decisions that need to be made, right? Those would be the decision variables. How many of product 1 and how many of product 2? We can call those X1 and X2. Because what we're doing first, we're understanding this problem, and then we'll write it out mathematically. But that's part of what we're thinking, is how are we going to write it out mathematically. Howie buys prefabricated fiberglass hot tub shells from a local supplier and adds the pump and tubing to the shells to create his hot tubs. This supplier has the capacity to deliver as many hot tub shells as Howie needs. So that's good to know, because that's not a constraint for this problem. Howie installs the same type of pump into both hot tubs, so good to know. He will have only 200 pumps available during his next production cycle. So each hot tub takes a pump. It takes the same pump, and he's going to only have 200 available. That's a constraint, 200. I'm limited. 200 will be on the right-hand side of that particular constraint, which we could call the pump constraint. From a manufacturing standpoint, the main difference between the two models of hot tubs is the amount of tubing and labor required. Each Aquaspa requires 9 hours of labor and 12 feet of tubing. So we have a tubing constraint and we have a labor constraint here, is what I'm getting from it. And for the Aquaspa, the coefficient associated with the amount of labor is 9 hours. It takes 9 hours of labor and 12 feet of tubing. 12 is the coefficient associated with the tubing for the Aquaspa. Each Hydrolux, the other model, requires 6 hours of labor, 6 times x2 is what I'm thinking, and 16 feet of tubing, 16 times the tubing, and this is x2 again, but it's a different constraint. We have a tubing constraint and a labor constraint. Howie expects to have 1566 production labor hours. That'll be the right-hand side of the hours constraint. And 2,880 feet of tubing, right-hand side. So however much tubing we use, it has to be less than or equal to 2,880. And however many hours we use, it better be less than 1,566. Howie earns a profit of $350 on each Aquaspa he sells and $300 on each Hydrolux he sells. So he is confident that he can sell all the hot tubs he produces. The question is, how many Aquaspas and Hydroluxes should Howie produce if he wants to maximize his profits during the next production cycle? That last sentence is nice. It lets us know we're trying to maximize profit, right? It also tells us in the sentence before that, or two sentences before that, that he earns $350 for every Aquaspa and $300 for every Hydrolux. So that's basically our objective function. 350 times x1, however many of those we make, plus $300 times however many times x2, however many of the second one we make. And we're going to maximize that. We want to maximize profit. So if we're maximizing profit, of course, the coefficients are going to be the profit. So this is how the problems come about. They unfortunately aren't floating around there mathematically. We have to read, understand, discuss, talk to people to try and figure out what the problem is and how we're modeling it. In the book here, we're going to be getting these little paragraph summaries of the problems, and it'll have what's significant, and it'll also have extra garbage that we don't need, so we need to identify the important parts and where they go. So first part is understanding. The first step in formulating a linear programming model is understanding the problem. So here it is, what we looked at just a second ago. One pump, each one takes one pump. That's each one has a certain amount of hours, each one has a certain amount of tubing requirement, each one has a certain amount of profit associated with it. Well, objective function is going to be in terms of profit, so that's our objective function. The other three are constraints, and 200 pumps, 1566 hours of labor, and 2880 feet of tubing. Those are our right-hand side of the constraints. So next, we're going to set it up mathematically. First, understand the problem. Write it down perhaps like this in summary format, and then we will write it out mathematically.